Watt, who invented the single-action steam engine 300 years ago, was a genius, using just the principle of boiling water to make the piston freeze. How does this thing work? The steam engine has a tank that holds 30 tons of water, which is piped to the boiler. The heat from the burning of the coal in the combustion chamber is transmitted to the boiler through the pipes, and the water around these pipes is boiled and turned into water vapor, which is collected in a dome at the top of the boiler, where it is circulated to the superheater. The purpose of the superheater is to heat saturated steam into superheated steam, increasing the water content of the steam and increasing the work capacity. The steam then passes through the piping into the piston system, which consists of two pistons, the upper secondary piston controlling the flow of steam, and the lower primary piston making the wheels move. Note that the steam first enters the left side of the main piston, pushing it to the right. At this point, the secondary piston also passively delays the movement to the right due to the connecting rods attached to the valves of both pistons. Notice the round hole in the upper left corner of the secondary piston from which the steam exits. When both pistons reach the right side, a cycle is repeated in the opposite direction, and so on and so forth to complete the continuous piston movement, pushing the wheel to keep running. Let's move on to the connecting rod system. At first glance it seems complicated, but in fact it is a main rod connecting all the wheels and driving the other connecting rods to move. The role of the connecting rod is to correctly operate the timing valve on and off. The valve can also be manually controlled, so that you can increase or decrease the amount of steam in the piston, so that the train accelerated or decelerated, similar to the throttle in modern cars. Here's another detail. When preparing to start the wheels, if the wheels were connected to the main rods at a horizontal angle, the movement would be stuck in place. Clever designers designed the wheel on the other side to be at a vertical 90 degrees to the connecting rod, in which case there would be no chance of all the wheels getting stuck at the same time. The steam engine has many pipes, all of which serve different purposes. The top of the headstock also had a dome for storing sand, which was connected to the pipes to be spread in front of the wheels to increase the friction of the wheels when climbing a hill. It must be said that the invention of the steam engine gave birth to the modern industrial society. The man who invented the air conditioner was a genius. A few simple steps can make a room very cool in the hot summer, so how exactly did he achieve it? We know that air conditioners are divided into two parts, the inner and outer units, and their internal essence is a device consisting of two sets of coiled copper tubes. The indoor coil is called the evaporator, responsible for heat absorption. The outdoor coil is called the condenser, responsible for heat release. Inside the tubes there is a liquid to conduct the heat, which of course is not water, but a more efficient substance called refrigerant. So how does the refrigerant work in this process? First of all, the refrigerant will enter a device called compressor. If the refrigerant is compared to the blood of the human body, then the compressor is the heart, the refrigerant cycle is the power it provides. Of course, now this piston compressor has been eliminated, was replaced by a quieter, more efficient vortex compressor, but the principle is the same. After compression through the compressor, the refrigerant temperature will become very high, up to 80 degrees or so, seriously higher than the outdoor temperature, which is conducive to the condenser through the fan to the coolant cooled down quickly. After cooling, the refrigerant at this time will also become a liquid state, but its temperature at this time also in 40 or 50 degrees. But it does not matter, the next step will enter the key. Refrigerant will flow into the inner machine in a device called the expansion valve. It will be liquid refrigerant quickly into a vapor state. You can simply understand it as similar to the principle of the spray can spray mist. As the refrigerant vaporization will absorb heat, there is a drop in pressure will make its temperature drop sharply. Then the temperature of the refrigerant will be reduced to 4 to 8 degrees. Then through the evaporator and the turbo fan and indoor air for efficient contact. Take away the heat of the indoor air, then you will feel the air conditioner blowing on you. The wind is cool. The refrigerant that has absorbed the heat rises in temperature and passes through the pipe into the outside unit before entering the next cycle. So how does it sense and control the temperature? The secret lies here in this expansion valve. The expansion valve is connected to a sensor that detects heat. The sensor detects the temperature change at the outlet of the evaporator and adjusts the flow rate of the refrigerant spewing out accordingly, thus keeping us cool and comfortable in hot weather. Let's take a look at how a three-phase asynchronous motor works in reality. First of all, let's understand what three-phase alternating current is. When rotating the magnet around the coil, the change of the magnetic field will make the coil produce alternating current. The waveform of the current is like this, which is unidirectional alternating current. 3 coils will be placed at an interval of 120 degrees, and then rotate the magnet. The waveform of the current is like this, which is three-phase alternating current. The three-phase asynchronous motor is connected to three-phase alternating current. The motor is mainly divided into rotor and stator, and the rotor is mainly composed of winding coils. First the coil enters from the A port, then comes out in the opposite direction from the A port directly opposite, then enters from the B port at 120-degree intervals, then comes out in the opposite direction from the B port, and then the same operation is done to connect the coil into the C port at 120 degrees. And finally the wires coming back in the opposite direction are connected together. The other three wires are connected to a three-way alternating current, and according to Ampere's law, when the current passes through the A coil it produces a magnetic field, the direction of which is clockwise. The coil opposite the other end of the A coil also generates a magnetic field, which is counterclockwise. B and C do the same, and you can visualize this change better with this diagram. When the green coil is energized with alternating current, the direction of the magnetic field in the green coil changes in the opposite direction as the current continues to change, regardless of whether the coil is red or blue. When all three coils are energized, this creates two separate magnetic fields. As the alternating current continues to change, the magnetic field changes with it, creating a rotating magnetic field. With a rotating magnetic field, we can build an electric motor. This is a simplified squirrel cage motor rotor. By placing the rotor directly into the stator, the rotor is able to turn quickly under the action of the rotating magnetic field. This is just a simple motor made up of windings. There are more complex windings, but ultimately they are all designed to create a rotating magnetic field. Asynchronous motors are used in a large number of applications in various industrial and agricultural production due to their simplicity, reliability, and ease of installation. The person who invented the anti-infantry jumping mine is really a madman. Instead of being buried in the ground like ordinary mines, which can only blow up the enemy's feet, it is capable of bouncing into the air after being triggered and delivering a fatal blow to the enemy's upper body, with a far greater power than ordinary mines. So how does it achieve this function? Let's take the M16 anti-infantry mines as an example to see its internal structure. M16 anti-infantry mines are mainly composed of two parts: the fuse and the body. The head of the fuse has three inductive rods, and inside there is a firing pin and a spring. The firing pin is held in place by a pin and does not move. When an enemy steps on the sensing rods, the rods move downward, driving a wedge that pushes the pin out, so that the firing pin is ejected by the spring and momentarily hits the primer below, thus igniting the delay charge. At this time the trip mine had not yet exploded, but waited a short time. This delay charge will ignite another propellant charge, which will push the mine body out of the casing and send it flying into the air. Note that this propelling charge also ignites the two detonators in the mine body, which detonates the main charge. When the main charge explodes, it ejects the steel balls in the body of the mine, creating a deadly kill circle. Now let's watch the whole process again. When an enemy steps on a jump mine, the jump mine first ignites the delay charge, then the propelling charge, which bounces the mine body into the air, and finally the main charge, which explodes in the air. In this way, the jumping mine can inflict heavy casualties on the enemy within a 30-meter radius. Jump mines usually explode near the enemy's waist, and that area happens to be the most vulnerable part of the human body, so many soldiers are very afraid of jump mines. In addition to pressure-sensitive rods, jumping mines can also be triggered by trip wires. The trip wire is tied to a nitro spike, and when the enemy touches the trip wire, it pulls the spike out, releasing the firing pin to ignite the primer, and ultimately leaving the enemy in a miserable state as well. Since the tripwire was so terrible, it was necessary to add a safety to him for safe transportation and storage. One end of the safety holds the firing pin so that it can't pop out. The other end holds the nitpick so that it can't be jacked out, and only then can the dreaded tripwire be contained.
These are miners extracting natural sulfur. It's one of the most dangerous jobs in the world. Many miners don't live past 50. Hence, sulfur is locally referred to as devil's gold. The temperature at the volcano mouth is consistently above 38 degrees Celsius. Nearby lies the world's most toxic volcanic lake. The air is filled with deadly acidic gases. During their work, they have to contend with two types of toxic fumes. One comes from deep within the volcano and emerges from these pipes. The smell of sulfur smoke is strong. It smells very sour, sometimes like rotten eggs. If it enters the nose or mouth, it can cause suffocation. If inhaled deeply, it can also cause stomach pain. These miners are temporary workers and have to buy their equipment. As a result, Most can't afford gas masks and instead use a wet cloth or towel to block the sulfur dust. The second type of smoke is even more dangerous. It's the volcanic gas from beneath the acidic lake. If it contacts the mouth or teeth, teeth will fall out. If ingested, it can be fatal. Thus, when miners see a thin white smoke rising from the lake, they immediately evacuate and wait for the wind to dissipate it before resuming work. These two types of fumes cause permanent damage, which is a primary reason for the miners' shortened lifespans. Despite having one of the most dangerous jobs in the world, they earn the lowest wages. It's not exploitation by employers, but because this sulfur itself is cheap. 98% of the world's sulfur is a byproduct of oil and natural gas refining and is very cheap. Extracting sulfur from these volcanic vents is outdated. They can only hire labor at a much lower cost, but this meager income sustains hundreds of miners and their families. Even though the wages are low compared to other industries, there are benefits. For instance, construction workers have to wait a week to get paid. If it's plantation work, it's a 2-week wait. Mining sulfur is extremely dangerous, but payment is swift. A common saying among the miners is, "We're not afraid of death, we're afraid of hunger."